The following program is sponsored by the Today's Home Remodeler television network.
Welcome to Today's Home Remodeler. I'm Stuart Keith, and on today's show, well, we're learning more about solar hot water systems. We'll begin by meeting with Kurt Hutter from H&H Solar Energy Services as he takes us on a tour of a local landscaping company that has converted most of their energy needs to solar. Next, we'll catch up with Justin Castleman from Castleman & Sons Plumbing, who designed and installed a solar hot water system in this new home. And finally, we'll finish up today's show out at the Plumber 75 Training Center to see how plumbing professionals are trained in solar technology. So we have a lot to cover today, and we'll get started after these messages. Anytime a business or homeowner in your community chooses to invest in renewable energy, we all benefit by lessening our dependency on foreign sources, reducing greenhouse gases, and leaving energy for future generations. So let's begin today's show with Kurt Hutter from H&H Solar Energy Services out at a local landscaping company that has converted their electrical power and heating to solar technology. Well, Kurt, it appears that this business is really taking advantage of solar technology.
Stu, what we have here is a large photovoltaic system that's doing a great deal of the power for the facility, and a solar hot water system, and it's zoned particularly so that they can turn off certain zones in the wintertime and then use the solar to heat their primary zones.
So are they going to realize a big decrease in fossil fuel usage?
The solar domestic hot water system will do up to 80 to 100% of their domestic hot water needs, and it'll contribute between 20 and 50% of their heating depending on how the system's zoned.
So the way you explain that, it seems to me this is a retrofit application versus new construction.
Correct. They looked at the programs and how they could reduce their use after the fact, and so in a retrofit situation, this is still an ideal way to put solar energy to use.
On earlier programs, we took a look at the photovoltaic or the solar electric side, but I'm anxious to learn more about how solar hot water systems operate. So let's start here with this array of collectors.
Sure, we have 10 4x10 solar thermal collectors here that are manufactured in the United States here in Florida, and we like to use American products whenever we can.
So as I look inside there, it almost looks similar to a radiator, or there's metal inside there, and those fins are actually heating up?
Correct. The manifold pipes in the bottom are of a larger diameter, and then there's multiple small diameter tubes that go up that are welded to a thin copper absorber plate with a black coating on it that absorbs the sun's energy. So as that fluid is pumped up and rises up through these capillary tubes, we'll call them, it gathers the heat energy from the plate and transfers it to the fluid back into the building.
So if I'm understanding you correctly, the sun heats up the metal fins that I see inside there, and then is this fluid that you mentioned always circulating through that, or just at certain times?
Nope, the fluid is stored in the building in a holding tank with a pump. And when the sun's energy is absorbed and the collector heats up, there's a sensor in the collector that tells the pump to turn on, and the fluid is then sent up through the array to gather the heat.
So it's like a giant heat exchanger out here and really taking full advantage of the essentially free energy that's stored in the sun.
Absolutely. It's a no-brainer. It's a perfect way to cut your bills and to take advantage of the sun's energy on a daily basis and put it to work.
So that takes care of the outside components. Let's head inside and see what's involved there.
Sure. Well, Stu, here we are inside the facility now, and this is the glycol storage tank, or drainback tank as it were. And what this is this holds the solar fluid until the system calls when the heat's available. The pump then turns on and takes the fluid out of this tank and sends it up to the collectors to gather the heat energy. The fluid then comes back through this heat exchanger and transfers that heat to the domestic water, which is in here.
Now, how does the heat exchanger actually operate?
This is a plate and frame heat exchanger. It's a double wall heat exchanger to protect the domestic water supply from the propylene glycol. Although it is a non-toxic fluid, the propylene glycol, we still want to keep our separation of the potable water and the non-potable fluid. So the plate and frame heat exchanger circulates the glycol through the plates in one direction and the domestic water back through in the other direction. That's where your heat transfer occurs.
And what temperatures are we talking at here? I mean, within this, looks like about a 300, 400 gallon tank. How hot is the water getting in there?
Well, right now the storage tank is sitting at 98 degrees, and within a couple of hours we'll raise that to 130 or 40 degrees. And over the course of a 4 to 6 hour sun period, we can raise this tank to 180 degrees.
180 degrees, so you can theoretically be bringing well water, again, 55 degrees, and raising it that much. So it's a very efficient system.
And then that heat energy from the water can be sent to various parts of the building for either heating or domestic potable water use.
And here, are they just using it for basic the lav or domestic
No,
water?
they have a locker room for the showers, and they use a great deal of water that they put into their power washers to clean their equipment, trucks, landscape equipment.
So it really makes sense for them. Now, this is obviously a commercial structure. What about residential?
It's the same technology and the same system and the same components we would put in a residential system, just economies of scale. This is a much larger system.
Well, it certainly is great technology that both residentially and commercially can save someone a lot of money. Thanks for coming on and introducing it to us.
Thanks for having me, Stu.
Stay tuned. We'll check out how this beautiful new home is using solar hot water when we continue with today's Home Remodeler.